Let's take a look at lesson 8.5. We're only going to focus on just the graphing part because I could ask you to solve systems using substitution and elimination. But again, we're just going to only focus on the graphing because we end up with different types of solutions. So thinking back to lesson 16.1, we solve systems by graphing. So if you remember, when we graph two lines, the solution is where the two lines intersect. Where they cross or where they intersect is your answer. So we did all of that in lesson 16.1. So go back and watch that video if you have to. And that's going to give you practice on how to graph the lines. In this lesson, I've already graphed them for you because we have three different scenarios, right? Three different situations or types of solutions. If the two lines intersect, I'm looking at number one. That means we only have one solution. The solution looks like a point because it has an x and a y. So if you remember from the past 4 lessons, we always get an x equals something and a y equals something. That means one answer, right? X and a y together. Our second scenario is if we have two lines that are parallel. If they're parallel, you want to always ask yourself, where do they intersect? And because parallel lines don't intersect, we have no answer or no solution, right? Because there's nowhere where they touch. And finally, the last situation is when two lines are exactly the same. So imagine if I were to graph a line, and then I graphed another line, but right on top of it, or right below it, then that means they're exactly the same line, and it would have infinite solutions. Because those two lines would cross everywhere. Or whatever point is on the first line would also be on the second line. That's infinite solutions. So we're going to see all three of these scenarios in the 3 examples below, and then I'm going to have you try 3 problems here before I show you the solution. So let's take a look at example 1. In example 1, you'll see 2 lines. They intersect. So you have to identify, first of all, you have to know that they intersect. And second of all, you have to be able to identify where they intersect, like what that point is. So knowing the coordinates of that, it intersects at the point -3, -2. Remember, it's the x first and then the y. For example 2, this one is just kind of tricky just because of the way it looks, because you see one line. But at the same time, it says in the directions, find the solution to this system. Because it says it's a system, it's implying that there's 2 lines there. So on this one, it is a system. There's 2 lines there. You can't see it because one is on top of the other. And that's going to result in infinite solutions since they intersect everywhere or they touch everywhere on its line. So it's infinite because both lines are the same line. And example 3. Now you can be very, very precise with this. You can see what the slope is because the slope tells us which direction it's going. So I'll just mention this really quick. From that point to, let's say, this point right here, it's going down 3 and over 2. Right, so that is the slope -2 over 3. That's rise and run. And you can see the same thing is happening here on the line below. It's going down 2 and over 3 again. So it's going the same way, which means it's parallel. And that leads us to no solution because these 2 lines will never touch. So I want you to try the other 3 problems before you see the solution here. Okay, here we go on the U tries. On the first one, because you only see one line there, we're assuming that the second line is right above or below it. That means it is the same line. All right, you don't have to mention that they're the same line, but this is just to tell us that they are the same line and they'll touch everywhere, and that means it is infinite solutions. All right, so this is the actual answer to the problem, to the system. On the next one over to the left, the two lines do intersect, and they intersect at the point -3, 1. On the last one, they are parallel, which means they'll never intersect, so no solution to that system.